Hello, and welcome to our webinar today, Automation at the Edge, 7 Use Cases Across Industries. My name is Michelle Knoll, and my colleague and friend Daphne Mendoza and I work in the Ansible Business Unit at Red Hat, and a lot of our work and collaboration supports the Edge domain. So we're going to share with you today a number of things. So we'll talk about the Edge across multiple industries and some of the unique challenges of Edge. And then we'll get into a bit of how Red Hat Ansible Automation Platform capabilities can solve those challenges. We're going to go through and spend most of our time going through real-world examples of customers and their Edge automation use cases and some of the results that they're seeing through adoption and deployment of Edge automation. So with Edge, we're thinking of this as outside the data center. And so the platforms are being extended outside the data center. There's a lot of heterogeneous devices that are spread across vast areas. And so things like on-demand applications and services are running closer to the data sources. So with adding more devices and services at the Edge sites, there's more to manage outside that traditional operations sphere. And so due to the evolving landscape, organizations do have new challenges that they need to address. They're looking at things like ensuring that they have the skills to address the evolving Edge infrastructure requirements. They're looking at being able to build capabilities that can react without human interaction. But that has to be done in a very secure and trusted way. So that's a critical component to that. And then they're also looking at effectively scaling at the Edge with this significant rise in devices and the vast number of endpoints that need to be considered. So let's take a look at some of the market perspective. And so why is Edge computing important? And so here, you need to have computing where it can do the most good, at the very place that you're doing business. And that's really where you're going to achieve value and drive that innovation. And so this means you need it on the edge. And so this could be whether it's the retail store, it could be a factory floor, a hospital, an oil rig, but you need your compute, your network, your storage, applications, analytics, those all need to be close to you, close to where your data is generated, the services are consumed, and where the end users are interacting. And so because Edge computing is local, decisions can be made faster, new services are offered quicker, and ultimately workers are safer, operational costs are lowered, and service delivery has fewer interruptions, even with a somewhat intermittent connectivity or potentially limited bandwidth. Edge computing helps you handle your data with confidence so that you know you're meeting compliance requirements and regulatory demands, and also with handling just personal information, intellectual property, any sort of critical sensitive data, and being able to handle that with the care that's needed. So taking a look at Edge at a glance. So in a recent IDC analyst paper that was sponsored by Red Hat a few months ago, so some interesting trends were identified. So the prediction that the total Edge market will reach over $273 billion by 2025. And so when you're looking at, as well, at like strategic investments of the organizations in this paper, they found that 73% of are in fact viewing edge computing as strategic and as a very strategic investment that needs to be considered. And then the other point on here, 54% of organizations planning to invest in Edge within 24 months. So a high percentage they're looking to invest. And then, not surprisingly with that, we also see increased spending in some of the supporting technologies and some other work that's been done. So areas like artificial intelligence, machine learning, Internet of Things, we're seeing increased spending trends projected in those supporting areas as well. So organizations across industries are realizing the significance of the Edge, and they're really seeing that Edge can create a competitive advantage for them. Some examples of that, for example, with manufacturing, they're seeing that they can combine Edge computing with artificial intelligence, helping to increase yields, reduce defects, in healthcare, providers are looking at leveraging edge computing and in order to automate MRI analysis and really with the goal of better and more accurately diagnosing patients. Retailers can better understand customer behavior and therefore offer a more personalized service. So those are just a few examples of what's happening across industries. And then in terms of challenges at the edge, there are a number of challenges that need to be overcome. So we're going to talk a little bit about those here. It's critical to be able to implement and manage and scale edge solutions, but it has to be done in a very secure and sustainable manner. And so safety and security is always top of mind, needing the ability to be able to run updates, patches, any required maintenance, and being able to do that automatically without sending a technician to the site. Reducing downtime is another. So really working to simplify network management, reducing network failure, boosting your bottom line. Improving efficiency is another. So increasing performance and reducing human error with automated analysis, monitoring and alerting in there. And then scalability and really increasing scalability, being able to apply configurations consistently across your infrastructure, and being able to scale edge devices more quickly. And then finally, agility and adapting to the changing customer demands using edge resources only as needed. And so next, we're going to take a look and get into a little bit more detail around Red Hat Ansible Automation Platform. And I guess to start off, we have this slide here because we wanted to give you a visual of what we mean when we're saying extending automation to the edge. So on this slide, you can see the core data center, the regional data center, cloud, and then the layers of edge outside that core. And so when you look at the distributed edge layer, things like servers, a gateway, network, example in that layer of edge and that distributed layer would be something like, for example, a remote branch office, or potentially at a bank, right, is one example. When you go to the far edge, this could actually include endpoints and all the way out to the devices and sensors. And so that could be anything from kiosk, in retail, it could be point of sale devices, wireless access points. And the point of this slide really just is to show you the scope of which or of where Ansible Automation Platform can be leveraged for automation, really all the way from the core data center and cloud all the way out to the device and sensor locations. So next we will talk about why using Red Hat Ansible Automation Platform. So the key with Red Hat Ansible Automation Platform really is being able to extend a very consistent automation experience across the scope that you just saw on the previous slide, across the cloud, the data center, and the edge, and really enabling organizations to build and manage and scale that entire, what's a very highly distributed, heterogeneous environment. And so having a simple platform like Red Hat Ansible Automation Platform is really critical to be able to do that. It's a single agentless tool, and it's enabling organizations to help standardize configurations and policies and deployments. And the benefit of that and the results that come from that are being able to improve security and compliance, as well as visibility, predictability, and repeatability. So having that common automation platform and being able to deploy the automation use cases. So developers are really able to build, to run, and manage these edge environments very consistently, and even out to those very remote locations where maybe the network connectivity is, intermittent and not fully consistent. So even being able to do that, and then having that interoperability, as mentioned, is needed across a very heterogeneous and wide ecosystem, really helping to accelerate innovation at scale. And so the key kind of word here is flexibility.
Exactly, Michelle. Flexibility. That's critical for edge architectures. And we want to show you how Red Hat Ansible Automation Platform has a flexible architecture that can adapt to your specific needs because we know that our customers will have different architectures regardless if they are part of the same industry. So there are some commonalities across edge use cases, kind of extending security, getting governance across all the edge landscape. But also you will have specific needs depending on your history, on how your infrastructure evolved. So what we are showing is that Red Hat Ansible Automation Platform can extend automation across multiple geographies, and it will adapt to your specific needs. We can deploy execution nodes, and we are going to show how this works depending on the location or your specific organizational needs. So you can have one by region, by city, by country, or by area, and you can adapt your infrastructure and also your automation infrastructure, and also adapt the execution to have redundant paths. So how Red Hat Ansible Automation is working, what's the re-architecture we had, is we split it. The control plane, which is the first layer, and the execution plane, which is the execution layer. Now the control plane will have the automation controller, and that will be the configuration point. So that's the interface, and that's the module that will be the connection point and the integration point. So it will be able to integrate with your company products and comply with your company policies, like integrations for user management, auditing, logging, authentication that has to be centralized, and provide the orchestration capabilities and provide workflow automations, for example. So the automation controller will be the brain of the automation. Now the execution plane, the execution layer, allows you to have distributed execution. And that's done through different features that are part of the architecture. The automation mesh is an overlay network, which allows to establish secure tunnels from the execution nodes to the automation controller. Now you can locate the execution nodes according to your specific needs, and you can also scale the automation across multiple domains like data center, cloud, or edge locations, specifically to your architecture. And we are also using a containerized architecture using execution environments. So you can test all the dependencies and move to production and start using the automation seamlessly. And when we are talking about flexibility, we are talking also about the ability to integrate what you currently have with your brownfield environment. And that means having supported and certified content. Michelle, can we talk more about the certified technology partners we have?
Yes, so with over 130 certified collections, and then as you can see the logos here on the slide, a lot of the big technology vendors in the space, we've got over 55 certified technology partners as part of this program. And so the benefit of that is really being able to speed up development and delivery to customers. And so as part of the Red Hat Ansible Automation Platform subscription, it's the ability to be able to leverage all of this, which customers are finding really helpful for speeding up that development and for continued innovation. So let's take a look now at some of the use cases across industries. So we know, right, overall with use cases, there are going to be some common threads and challenges and scenarios that maybe in some way, apply to the different industries. But there's also some unique differentiators that are happening in the different industries. And so as a result of that and getting a lot of questions from customers and prospects around use cases and industries, we just finished a development of an ebook around use cases a few months ago. And as a big part of that effort and development of the ebook was around a series of interviews with subject matter experts in 7 industries is what we chose. So we're going to take a look now and spend the rest of our time really going through these industries. So we're going to start with transportation. We're going to cover retail, With Industry 4.0, we'll cover, for us, we're going to look at manufacturing, energy, oil and gas within that Industry 4.0, telecommunications, financial services and insurance. And then we'll also talk about smart cities and healthcare and some things that are happening there. So let's go ahead and get started with transportation. So modernizing transportation to be smart, safe, efficient, that's no small feat, right? Like there's a lot required there. And so, and along with that is meeting customer demands and expectations. That's always top of mind. And so take a railway, for example, the company say that they wanted to include intelligent features in some capacity. Well, without a central control, they'd likely have to go to, in the rail industry, for example, they'd have to go onto every train and manually check or update or fix each device. And when you think about the time and resources to set up and maintain that, it's unfeasible. That's just not reasonable. And so what some of the automation at the edge benefits that are being realized in the transportation industry are around reducing configuration times with automation, enhancing security and uptime for critical transportation infrastructure, and establishing comprehensive device access for easier service updates and innovation. So those are a few things happening in transportation. And we'll talk a little bit next about Industry 4.0. And again, we're looking at, in this sector, we're looking at manufacturing, energy, and oil and gas. So some of the key challenges here are around safety. Safety is huge in the industrial realm when you think about the fact that things can literally explode if something does not perform properly. And accidents are a huge concern. Worker safety is a top priority for many in the industrial space. Operations is another key focus area here, and can have a major financial impact. So the importance of being able to minimize disruption, improving quality control, reducing downtime, and just minimizing human interaction for the repeatable tasks that can be automated. And then another key aspect here is making the resources that IT has and making those available, extending out to the operational teams in the OT world. For example, operations on a factory floor or in an oil field, right? And so making those IT resources available to and extending to the OT realm. And then we'll also take a brief look at smart cities here. And so with smart cities, I think a good illustration that we can use to talk about some of the opportunity in smart cities and automation at the edge is an example like traffic cameras. So if you think about an edge device like a traffic camera, so a single traffic camera has the potential to capture data about any number of variables. It could be something like road conditions, weather, traffic patterns, congestion, emergencies, things like that. So edge computing is really helping these devices with gathering and processing data that's coming in near real time, and using that data to make decisions and take action. And so, but if you multiply this across a large city, and it would quickly become impossible for technicians to respond to that data in a reasonable time. And then when you add to that the burden of security and patches and updates, it's unfeasible, and it could also, increase the risk of security threats and disruptions and things like that. So automating the decision process at the edge can help cities deploy services efficiently and respond to emergencies, and really to plan for the future. And an example of that, just to take the traffic camera example one step further, would be detecting an accident at an intersection and then perhaps automatically adjusting the traffic lights to block traffic while the emergency services are being notified. And all of that could be done with automation, potentially without human assistance. And so just really allowing that to happen, those first steps, and then maybe a team member could come out and better assess the situation in person. But some of those critical first steps could be taken with an edge automation use case. All right, and next we will go into retail. Daphne?
Yeah. Thank you, Michelle. This was amazing. What we are seeing is that across all the industries, there are some drivers, right? We can see that one common is regulations, security, the ability to gain governance across all these heterogeneous and complex environments, but also the change in consumer preferences. And one of the sectors that was mostly disrupted was retail. And you can see, if you assess yourself as a consumer, now we really want to get fast delivery and have an omni-channel experience. You want to buy using your mobile application, the web page, and you also want to have a good experience when you are in the store. Something that's interesting for our retail customers is also the ability to manage their stores, kind of a store in a box or a store as a code, because they are having the need to relocate some of the infrastructure. They are opening or closing stores, and they can do that for thousands of locations per year. So if you add up all the efficiency that you need to deploy a store, that's really a big deal, because we are talking about Wi-Fi access points, multiple points of sales, also the scanning devices. It's interesting also that retail is transforming how they manage the inventory. Now they're using AirTags and dark stores, even adding some robotics to improve the inventory accuracy. And all this technology and transformation really needs to have all the security layers and controls in place. And that involves using automation. And at the end of the day, it's here about auditing these new devices, hardening the security, hardening all the components so all of them are secure, enhancing the customer experience, and ensuring consistency and managing all the life cycle for all the applications and infrastructure. And kind of similar drivers, but different, are for telecommunications. I worked a very long time with telecommunications, and what happens is that you used to deploy changes during the maintenance windows at night, and you will have a 8-hour window. What happened after the lockdowns is that users are using internet more than ever, and now the bandwidth utilization is almost consistent all over the day. So the maintenance, the impact that you will have by having a downtime is really critical for your consumers, and they might even open Twitter threads, and this can become a PR problem for a telecommunication service provider. Now, what are our customers doing? They are implementing telemetry to proactively support the customers. Now they are also shortening the time to deploy new services, and this means also deploying and decommissioning services. And this could be B2C services or B2B as well. And something that's becoming critical is mitigating the network downtime. That includes for patching, updates, deployment of configurations, and also migrations. Now, downtime became critical, and that involves efficiency and human error reduction. Human error is the biggest risk here. And if you can simplify the maintenance window, test before deploying the changes, and then shorten the implementation and automate the rollbacks, that's really important for telecommunication, because you will be able to manage the network configuration states. And something that's critical also is increasing the network efficiency and limiting the need for human intervention. And at the end of the day, it's all about improving the overall customer experience and also complying with the regulators. If you have a big downtime during the day, or if you extend the maintenance window, you will be forced to pay a fee, usually in multiple countries. So it's critical that you keep the network uptime the most as possible, the highest as possible. Another sector that's also transforming is financial services. And if you think about it, you will hear about fintechs and all these new financial service offers. But also you will see that financial sector has been one of that was the most targeted by hackers during the last 10 years. And what happened is that with financial customers, is they are proactively also trying to renew their infrastructure. They have a lot of migration use cases, new applications, and they are trying to be more proactive with all these security risks. And they also have to maintain very strict security standards. And this could be trying to be compliant with the internal auditors, but also due to the changes in regulations. This is one of the sectors that's highly regulated, and it's important to be able to have a better implementation even than what the regulation requires, because the regulation will keep changing. And here is also one driver to provide a more personalized customer experience, consumer experience. All of us are financial sector and customers. And you can see also, if you observe yourself, the changes in your consumer behavior. Now you have the bank application in your cell phone. You also use the online service, the call center, and you really want to have permanent connectivity and access to all your payment services. Now, here, downtime is also becoming critical. If you had previously the time to have a long maintenance window, you don't have it anymore. And finally, let's go to healthcare, which is one of my favorite use cases. We are going to have one customer story that's very compelling, and I think it will cover all the details. But when we are talking about healthcare, here it's a matter of life and death. So it's critical to use technology so you can monitor what are the patient's symptoms, what are the changes, and all these signals, so you can provide an earlier diagnosis, and also you can connect and notify to the physicians, to the nurses, to all the healthcare personnel on what's happening with the patients that might be in other locations. So you can really improve the delivery of care in remote locations, and you can also improve the people's lives through technology applied to healthcare. So how do you manage the automation here? Is to manage the life cycle of all these applications and all the infrastructure that supports the healthcare. So what we have seen is that customers are starting to use machine learning, AI, to improve the diagnosis. And that was even used to track and deploy vaccines and other medications as needed during the COVID pandemic. We are going to see some of Red Hat customer success stories. We want to hear from some of you, Michelle.
Yes, so we'll start with Alstom. And so we'll start in the transportation industry. So Alstom, if you're not familiar with, Alstom is a global leader, and they develop and market mobility solutions. And those solutions provide sustainable foundations really for the future of transportation. Alstom has operations in over 70 countries, and the scope of what they do includes high-speed trains, metros, monorails, trams, and it also includes things like turnkey systems, services, infrastructure, signaling, things like that. And so Alstom developed an edge computing strategy built on Red Hat Enterprise Linux and Red Hat Ansible automation platform. And so looking at some of the challenges and results that they saw. So there's a few things that bubbled up to the top here with Alstom. One was agility. And so if you think about the size of a rail network, and there may be thousands of devices running software. And so the patching of those applications and the underlying operating system software, it must be automated in an edge infrastructure when you think about just the vast number that needs to be dealt with. And so they're able to automate the life cycle of thousands of trackside devices, and in doing so, significantly reduced the manual processes that were previously taking place. They were also able to securely and reliably and easily do things like testing and scanning and deploying the edge applications. And then the second is around security. And so there are concerns certainly around hacking, for example, a nation's transportation infrastructure. And so the need of having complete control of end-to-end hardware and software is required in a railway network. And so they were able, at Alstom, they're able to gain and apply open source best practices for improved cyber hardening. And then the third is around response time. So with the thousands of devices in a rail network, the speed of responding to events is essential. And so in order to handle continuous communications and to minimize downtime. And so leveraging Red Hat Enterprise Linux and Ansible Automation Platform enable them to fix equipment and reroute vehicles in real time. So that's one in the transportation sector. And I also will share one in the retail world. And this one is around Schwartz IT. If you're not familiar with Schwartz and some of the brands that it encompasses, for example, Lidl and Kaufland, so they're the fourth largest retail. They have over 12,000 stores, and this is spread over 33 countries. And so what they were challenged with is they really needed to ensure consistency in their store management across thousands of stores worldwide, including Germany to the US. And so they needed to balance that consistency, though, with being able to be flexible with adapting to local demands that might be happening in a particular country or region, as well as the agility to open new stores quickly. And so with their goal of staying competitive, they really needed a centralized automation platform, and they chose Red Hat Ansible Automation Platform for that. And so taking a look at some of the results that they were able to realize, they were able to implement and centralize this strategy globally over their 12,500 stores. They were able to improve the delivery time for these new innovative applications and digital services that are continuously coming out. They're also able to support local markets. Again, that was mentioned, I mentioned that previously as being something that they needed to do. They needed consistency, but they also needed to be able to support and differentiate for local markets. They were able to do that through decentralized management. And then they also gained expertise to operate Ansible Automation Platform in-house. And this was backed by, and for them it was really important that it was backed by enterprise support through their Ansible Automation Platform subscription. So Daphne, you have another example to share?
Yes, I have two, actually. One is Siemens, and this is an Industry 4.0. And what they did here is they had all these public key infrastructure environments, and they use it basically to generate, assign, issue, and manage all the life cycle of the certificates. Now they do that because they need the certificates for the people that's connecting to their network, and also for their third-party partners and for specific products. Now they have been using this certificate infrastructure, the PKI, for more than 10 years, and they issue more than 120,000 certificates per year. Now, if one certificate expires, that means that you are out, basically. So, and it's not a simple task to do that manually. You have to generate the CSR, sign it into the specific certificate authority, get the certificate, copy, install it, and basically replace the old certificate. So they managed to automate all that certificate management workflow, but also they managed to certificate their public key infrastructure as code. So they have the production environment, they also have the QA, the testing environment, and the development. And they can also manage here all these virtual machines that will have the certificate, the PKI components, and test them. So they can install and test the software versions before moving to production. That improves the configuration quality, but they also are strengthening the communication security throughout the whole company. And this is my favorite, the HCA Healthcare. I mentioned it. What they are doing is they are developing predictive analysis using Red Hat software. Now they are using multiple components. They have a Red Hat OpenShift container platform and Red Hat Enterprise Linux to create all this container-based platform as a service foundation. They are using Red Hat Ansible Automation Platform to provide the broad automation capabilities for the data collection, analysis, and proactive notification. Notifications is something that you usually do not think about being part of the automation, but that's needed across all the customers. You need notification services, messaging approvals, mails, or Slack messages, even Telegram. So all the notification can be done through automation. And they also have Red Hat Satellite and Red Hat Insights for management and analytics for the environment. And on top of all this infrastructure, they implemented their own development. What does that development do? What does the application they develop do? This is sepsis prediction and optimization of therapy. What happens with sepsis is that 1 hour delay of diagnosis increases the risk of death from 4 to 7%. And it's hard to diagnose. So they are taking all these signals, all the information on the on the patients, and all that information is being injected into their machine learning algorithm, and they will have some notifications to the nurses or to the physicians. So the outcome here is that they are having up to a 20-hour early warning. They are really saving lives by early sepsis detection. This is running for years, and they are using all the technology to have all this container environment platform to run the application. And why they are using Red Hat? They did the development by themselves using open source, but they needed to have a supported environment. So if something breaks, that cannot happen. The application has to run. So they really need to have enterprise SLAs and have a supported environment. And that's they partner with Red Hat. And they are independently implementing and also removing the development environments to maintain the application. Now we have 2 more ongoing use cases. These are ongoing, so we are not going to mention the customers, but this is common across oil and gas companies. Here, this is the automation for human-machine interface. And basically, these devices are kind of you can think about an iPad, a tablet component that will have one application installed. So all these low power, low processor devices, the HMI, are taken by the operators into the remote locations, into the field, but they have to update the application and check for patches in a regular fashion. So when they are into one of the plants, they can plug in the HMI device and click on a button on the HMI panel. And what the automation will do, what Ansible Automation Platform will do, is it will connect into multiple components and manage all the dependencies. That means certificates, DNS configuration, IP address reservation, credential rotation, system patching, security log forwarding, plus the application installation and configuration changes. So if you have a patch here in these HMI devices, you will have to manage all the dependencies as well. So they are simplifying all this patching process, but also the hardening that's involved. And finally, the smart building use case. Here, this is a smart building that will have a data center, and the data center has all these sensors. Data centers are critical infrastructure that needs to have everything under control. Temperature sensors, humidity, battery, energy. If you have seen a data center without energy, in 2 minutes, all the servers are about to collapse. It's really critical. So here, what they are doing is they are integrating Red Hat Ansible Automation Platform with the BAS, the Building Automation Management System, and the ETMS, the Enterprise Trouble Management System. And they are getting all these sensors information. And if the KPIs, if the levels that are passing specific thresholds, it can also send notifications or trigger remediation automation, depending on what are the specific policies that our customers will have. So those are two interesting use cases. We have more. We don't have much time. I'll let you, Michelle, end the presentation. We have some resources.
We do, yes. So we have several that you can check out to learn more. We have one IDC piece that was done, automating the last mile, that you see here. And then we also have linked the ebook that I referenced earlier at the beginning, the use case ebook, and that you can obtain a lot more detail about what Daphne and I discussed today if you check that out. And then also linked is the Red Hat Ansible automation platform, the Edge use case page that has a lot of assets on there as well. And then we also want to mention to the audience that we do have our large event coming up in October 18th to 19th in Chicago, Ansible Fest. We're so excited about this event. Daphne, I know you have a couple specific things that you're really looking forward to, but it's going to be a great event. Please take a look on ansiblefest.com. Daphne, will you want to share what you're most excited about?
Yeah, I'm mostly excited on the customer experiences. We are going to have some OT customers, gas and oil, multiple industries that are going to share telecommunications. So all the industries you hear about, plus public sector, are going to be present, and they are going to share their experience, best practices, and we are also going to have partners present and very cool announcements during the event.
Yeah, such a great opportunity to collaborate and talk firsthand to some of the really awesome, innovative work that's happening globally. Well, with that, we thank you all for your time, and that concludes our presentation, and we are ready to take questions. Thank you.
Here, yes, I have one. I answered that internally to Alberto, and this is the security one. We actually build these use cases, and we have all the documentation around what are the main concerns that our customers have. And the first one we have, the first concern is protecting the edge compute. And that means protecting the data. That means extending security controls. That means managing certificates and having compliance use cases, remediation use cases, and at some point have self-healing. Now we covered all the variety on how our customers are implementing security and hardening, but we are also working on having more documentation on the use cases. And I think automation is critical. And the first starting point is standardization. And trying to reduce the human interaction per device. I know that's how we started doing things and how we were trained, that you connect and you configure manually device by device. But that approach actually introduces a lot of human error. And the main security issues we have with customers are driven by users that are tampering devices, that are connecting routers that shouldn't be there, that are disconnecting devices to plug in other appliances. So if you can have everything standardized, the most as you can, and automate everything, that will be the best approach, because you have a controlled environment to start. So that's the first. And actually, we are also focusing on extending the security controls that you will have that are common in the enterprise architecture, and that are also common in the data center. The physical security, it's very hard to extend, but the logical security you can, like extending the controls of CM, SOAR, access list, and firewalls. And if you can extend security, you can also automate that. So that's what we wanted to summarize, because that's the main concern. And Michelle, I think you had also one question.
Yes, I see a question around, so needing to deploy an application in remote servers. And the question is, do we have or do we provide any reference on how to do that, something like that with Ansible? So here I can talk a little bit about something we have at Red Hat called validated patterns. So we see these as a sort of a natural progression from reference architectures with additional value. With these patterns, typically they'll include one or more applications, and they're all based on successfully deployed customer examples. So it's something that customers are finding really helpful to be able to leverage and get started. It's the example application code is provided as a demonstration, and then the users can modify the pattern based on their own specific application. And so as there's a process to get something to be a validated pattern, and they often look for these sort of novel, repeatable customer use cases. And just to really, customers have found it helpful as a way to just really get started, a lot quicker. Do you have anything to add on that, Daphne? I know you've done some work with validated patterns as well.
Yes, and there's actually the application deployment that's ready, and it's actually the Ignition application, the container image. So that use case is ready, and it's ready upstream. We are going to have several announcements as part of the Ansible Fest. And there are also some validated pattern and validated content development for networking use cases. If we think about Edge, it's also about connectivity. All of these distributed architecture have some sort of networking connectivity to work. So if you can also automate, and you can also have some batteries included on the automation content for the networking management. That's also very useful for our customers, and that's what we are working on right now as well. And we also had one that's more conceptual, and it's actually good to tackle that. And it's what's the main difference between cloud and edge. So the main difference here when we are talking about edge is the ownership. And that means also risk ownership, because here the edge infrastructure is yours. So you have to manage all these distributed routers, switches, Linux devices, sensors. That's under your own domain of responsibility. I mean, on the IT or OT teams. So that's the company responsibility to manage, to have the governance across all these devices. And we mentioned a lot about the heterogeneous world. That means because, and we are using that word because we have networking, compute, applications, containers, like everything depending on the customer needs. And our customers are actually managing all of these components, and they own these components. So here is also who should manage all this infrastructure, what's the team that should be doing the patching, what happens in the case of a vulnerability, what's the team that should be configuring and having the ownership, the responsibility of the infrastructure. In Edge usually is our customers or our customers, right? That are having all this infrastructure managed by some sort of partner. I think that's the main difference. These are the questions we have. I don't know if there is someone we didn't address.
Yeah, I think we've got all of them here covered. All right, well, thanks everyone for joining, and take a look at the resources and let us know if you have any additional questions. Feel free to reach out. Thanks, everyone.